Number 1, what is the y-intercept of the line graphed? When we are provided with the graph of any function, it doesn't have to be a line, and they ask us for the y-intercept, they just want to know where this line, this function, crosses the y-axis. And this is our y-axis right here. So this line is crossing it. As we can see, this is 4, and that's 6, so this is 5. And the coordinates for that, we always list the x-coordinate and then the y-coordinate. The x-coordinate is here 0, so it's 0 left and right. And then we go up 5, 0, 5 is our answer. That is our y-intercept. If this had been given in an equation form, most commonly we see things in slope-intercept form, where there's an x, there's a y, and then there are two numbers represented here by m and b. M is going to be your slope, and b is your y-intercept. So if it was like y equals, I'm not sure what the slope on this one is, but let's say like y equals 1/3 x, I don't know if that's what it is, I have to check it, plus 5, that 5 there is telling us that where the y-intercept is. So that's just something to look for if they give it to you in equation form, but here again they're giving it to us as a graph, so we just look on the graph, and right there is where it crosses the y-axis. Then you just have to be careful that you're entering the coordinates correctly, and there's your answer, C. Number 2, we have a chart. It says type of store, warehouse store, department store, supermarket, and average number of employees, 365, 213, and 130. For a certain region, the table shows the average number of store employees in 2016 by type of store. Based on the table, how much greater was the average number of store employees in warehouse stores than in supermarkets? This is just testing our ability to read a table. So let's compare. Let's find this information. Let's see what they want us to compare, and we'll compare it. They want to know the average number of store employees in warehouse stores and the average number of store employees in supermarkets. So first, in warehouse stores, the average number of employees was 365. Okay, so for the warehouse, the average was 365. And then in supermarkets, the average was 130. So I say supermarket, I'm just really abbreviating here, it was 130. And we don't have to do any math to figure out the average number of employees because the table says it's giving us the average number. A lot of times when we see the word average, we're thinking of mean, like mean, median, mode, and taking the average of numbers, but that's not necessary here. The chart is giving us the average. We don't have to calculate it. What do we have to calculate it? The question is, how much greater was the number of warehouse employees versus supermarket? How much greater than? That's going to be a subtraction problem. So 365 is the bigger number. How much greater is it than the supermarket number 130? So we would just slide this over a little bit and we would just subtract these two and we get 235. And that is C. That's my answer. Number 3, note, figure not drawn to scale. Anytime you see that figure not drawn to scale, it's not telling you that it's drawn wildly different from what it actually should be. It's telling you don't try to look at this figure and deduce the answer by going, well, this angle looks about 123 degrees or 147 degrees or 57 degrees. So that's how I know it's the answer. No, it's just giving you a basic reference, but it could be off. So let's look at what they're telling us. We have to go by what they're telling us. In the figure, line M is parallel to line N. Okay, so line M, didn't quite draw that little M and N. Okay, those are parallel. That's how we indicate lines are parallel. M is parallel to line N, and line T intersects both lines. What is the value of X? This is the geometry concept of parallel lines crossed by a transversal. Normally we draw the lines horizontally, so seeing them vertically can be a little bit of a huh, but it's the same difference, exact same thing. So if I have two parallel lines, that is lines that have the same slope and that never, ever, ever cross. And then we have a transversal, that's a line crossing it. It could be crossing it that way, it could be that way, that way. It really doesn't matter. Just there's a line crossing the parallel lines. When this happens, it creates two identical intersections. Now, in your geometry class, you will have a lot of theorems and things that you have to learn, like corresponding angles are similar and same side interior angles are supplementary, and exterior same side exterior angles are supplementary. Things like that, because you're using them in proofs and theorems. You do not need to know those names for the SAT. Here is what you need to know. It's just the corresponding angles part. So, and I'm going to use highlighting colors here. So let's use like a kind of neon purple. So these two angles, they are also called opposite or vertical angles. Anytime we have intersecting lines, the angles that are opposite each other are congruent. So those two are the same, and they are the same as these two. So these four angles are all identical. Then we have, let's do like neon blue. Then we have that angle, and that angle, that one, and that one. Those all match. And now as you can see, like one pinky purple and one blue, they make a line together. So these two pairs, these opposite colors, they are always going to be supplementary. That is, they add up to 180 degrees. That's what you need to know. You need to know that it makes two matching intersections. So like the top left on this intersection will match the top left on that intersection, which will match the bottom right and the bottom right. This little chart is all you really need. And then you can look at that chart and go like, oh, so the two colors, the opposite colors, they make a line, so they're supplementary. So then once we have that those colors are supplementary, that pink would then be supplementary to that blue, etc. That's what you need to study. Don't, for this test, not for your geometry class, but for this test, don't worry about memorizing the names of all those theorems. Just memorize this chart. So let's kind of spin this chart over, make it vertical, and then we can see what's going on. And I think is it going to let me do it? Sometimes it likes it, sometimes it doesn't. So it's like, is it going to let me spin it? No, it's having a day. It doesn't want to let me spin it. It'll make, like you can make it bigger and smaller, but you can't spin it because that would be helpful. Anyways, it's the same principle. It's the same principle. Fine, Microsoft, I will draw it vertically and then we'll do it that way. Just you're going to see it in your math books horizontally. That's why I tend to draw it that way. But it's the same thing. So we got our little matching ones there. And then we have our matching ones there. Same difference. So looking at our chart that we're given, which I have crudely recreated over here, they want to know the value of x, and we are given the value of this angle down here, that it's 33 degrees. In my chart, it's one of the blue ones, and my x up here is one of the pink ones, pinky purples. They are opposite colors. They are supplementary. That's it. So together, they add up to 180 degrees. So to solve for this, since it's x plus 33 is 180 degrees, I need to undo what's been done to x. 33 has been added, so we need to subtract 33 from both sides, and we get that x is equal to 147, and that is degrees, and that means my answer is D. But yeah, just this, that's all you need to know, is that all the matching colors in that chart are congruent. So all the pinky purples are congruent to all the other pinky purples. The blues are congruent to all the other blues. And every blue is congruent, every blue is supplementary to every pinky purple. in my little chart that I've made there. Don't memorize the names, just memorize that. But do memorize that. It's important. Number 4, Sean rents a tent at a cost of $11 per day plus a one-time insurance fee of $10. Which equation represents the total cost, C, in dollars to rent the tent with insurance for D days? On some problems, I recommend looking at the multiple choice answers ahead of time or before you tackle the question. This one I really don't. I think it can cause more confusion. The only exception to that would be is if you look at this problem and you attempt it and you really don't know where to start, then by all means do look at the equations that are provided in order to kind of get you jump started and thinking in the right direction. But if you have a good idea of how to deal with these problems without looking at the answers, I would suggest holding off and starting with it. So what do we have here? He's renting a tent and it's $11 per day. When we have per, this is talking about multiplication. So how many days does he have it? It's D days. So without talking about anything else, let's just think about what it would mean if he has to pay $11 per day. And let's say he had it for 5 days. It's $11 for every one day. $11 per day. If he had it for 5 days, how would you find out how much he had to pay? Well, you would multiply 11 times 5. It's 11 each day. It's 5 days. 11 times 5. Since we don't know the number of days and we're told to represent it with D for days, we will call this 11 times D, and that represents the amount of money he has to pay for the plain rental per day cost. Is there anything else he has to pay? Well, if we look at our equation our word problem up here, we see there plus, it's already there, plus a one-time insurance fee of $10. Sometimes we have to figure out what we need to do, but here it's right there. It's plus. We need to add. We need to add a one-time insurance fee of $10. And that altogether will be his cost. And it tells us that total cost should be referred to as C. So the total cost is $11 per day times the number of days plus the $10 one-time insurance fee. C equals 11D plus 10. And that gives me my answer there, C. And see, when you look at the other answers, they give 11 times D plus 10, 10 times D plus 11, and 10D plus 11. Because they are so close when you look at them visually. That's why I think it's easier to, just do it yourself first and then compare it. Because if you just glance at it, one of those may look correct because they are very similarly written, and then you can end up getting it wrong. But again, like I said, there's no shame in, if you're forgetting how to do it, looking at the answers to give you a clue. In fact, they're really good for that, at giving you clues when you've forgotten something, or you're just getting oh, I don't know where to start. The answers can be a great place for that. All right, again, answer there is C. Number 5. We have a triangle with sides A, B, and C, and a note that the figure is not drawn to scale. As I mentioned in an earlier problem in this section, when it says the figure not drawn to scale, they are telling you don't look at this and eyeball it and go, oh, it looks like it's about this long, so that must be my answer. It will not work. For the right triangle shown, A equals 4 and B equals 5. Okay, so A is 4 and B is 5. Which expression represents the value of C? Not going to lie, I was surprised by the answers that they gave here. I thought they would be trying to trip students up by making them think this was a 3, 4, 5 right triangle. This is a very common right triangle. It's this perfect little 3, 4, 5. They like using it a lot. Also multiples of this work, so 3 times 2, 4 times 2, 5 times 2. That also is a perfect right triangle. And I thought, oh, they put the A in 4 and B in 5, and they're trying to see if students put them on the wrong side and think it's a 3, 4, 5. But no, 3 is not provided as an answer down there. So it's just be aware of stuff like that, because this time they're being nice. They are not usually nice. And they often will put answers like that that are trying to lead you down the garden path, as the very old saying goes. But here they're being kind of nice. So they are just doing a straight test of your knowledge of the Pythagorean theorem. Pythagorean theorem says that when I have a very poorly drawn triangle that is a right triangle, meaning it has a right angle, a 90-degree angle in it, the length of the sides can be compared by saying that the length of A, the side A squared, plus the length of side B squared is equal to the length of side C squared. That's the Pythagorean theorem. So here, if we are trying to solve for C, we know that A is 4, that B is 5, and that is going to be equal to C squared. So what is the value of just C? Well, if we have algebra, we know that we can undo things that have been done, but we have to make sure to do it to both sides. That keeps it balanced because it is an equation, so it has to stay balanced or equal. C here is being squared, so we need to undo that. We need to take the, go with green, the square root of both sides. And that gets me my C all by its lonesome. And on the left side, I have the square root of 4 squared plus 5 squared. And I don't have to go any further. And this is a case where, having noticed that the answers all just have 4s and 5s in them is helpful. Because if I hadn't kind of seen that, not necessarily looked intently at this to start with, but just kind of glanced at those answers and said, hey, they all involve 4s and 5s, then I would know I don't have to go any further than this. I don't have to go, oh, well, 4 squared is 16, and then 5 squared is 25. 16 plus 25 is 41. You take the square root of that. That can't be simplified. I don't have to. I don't have to do that because it keeps it in terms of 4 and 5. So I just get to that point, and I have my answer, square root of 4 squared plus 5 squared, and that is D. Number 6. The function g is defined by g of x equals 6x. For what value of x is g of x 54? Functions are about inputs and outputs. When you have what we start with graphing, when we start things like, say, y equals 6x. With this, they're equal in the sense that, like, I can plug in y and solve for x, and I can plug in x and solve for y. Now, while we can also solve for both variables in a function, the flow of it is different. When we have a function, what it's saying is, and I'm putting f of x is the most common, but here we're using g of x. It doesn't matter. It can be any letter, of x. When we say that these equal 6x, it's saying if I put a number in here, let's say I put in 2, what would be f of 2? If f of x equals 6x, what is f of 2? So, okay, take 2, then I go over to my equation on the right-hand side. Everywhere that there's an x, I plug in a 2, then I do my math, 6 times 2, and I get 12. So f of 2 equals 12. F of x being the most common variation. So that's the process, input, output. So it's a little different phrasing, but it's the same sort of thing. So this one they're calling the function g of x. So for this one, same sort of thing. A number is being plugged in for x. You do the math, you multiply 6 times it, you get an output. What is it? So here it's saying g of x is 54. The output was 54. So I can plug that in right there and saying 54 was my output, my g of x. What x did I plug in to get this output? Well, now I have a much more sort of straightforward algebra equation. If 54 is equal to 6 times x, I want to solve for x. I need to undo what's been done. X is being multiplied by 6. The opposite of that is division. So I'm going to divide both sides by 6. So on the right side, the 6's cancel out, so I just have my x left behind. And 54 divided by 6 is 9. So that is my answer, 9. And you can double check that by saying, okay, if g of x is 6x, if I plug 9 in, g of 9, then I put it everywhere here. 6 times 9, 54 is my output. Yep, that is correct. 9 is my answer. Number 7. The function f is defined by f of x equals 8x cubed plus 4. What is the value of f of 2? If you just watched my one for question 6, this is going to be repetitious, but I explain each time just in case someone's watching individual problems by themselves. So f of x equals 8x cubed plus 4. When we have a function, it is input and output. So the function f of x equals 8x cubed plus 4. What they're saying is any number for x, if I plug it in there, so let's say f of 1, f of 5, whatever we're trying to f of, whatever it is, you take that new value for x, and everywhere there's an x in that equation, you plug it in. And then you do the math, and the result that you get is your answer. So this one, they are saying, what is f of 2? So I take my equation, 8x cubed plus 4. There's only one x here, so I'm going to replace that with my 2. So 8 times 2 cubed plus 4, and now I just need to do the math. And the only really thing you have to be careful of here is to make sure you're doing things in the correct order of operations. So here I have an exponent. I need to do that first. So 2 cubed, 2 times 2 times 2, that is 8. So I have 8 times 8 plus 4. Then multiplication comes next. 8 times 8 is 64. Zoom out a little. And then finally, I can do that last addition. 64 plus 4 is 68. And that is the value of f of 2, 68. That is my answer. Number 8. The function f is defined by f of x equals 1/10 x minus 2. What is the y-intercept of the graph of y equals f of x in the xy plane? You can do this by graphing. I don't recommend doing it that way because while yes, it will absolutely give you the right answer and it's a great backup to use, we always want to use, it's two sort of caveats. We want to use the one we're most comfortable with. And when I say comfortable, the one that you feel comfortable that you can get the correct answer with. That's got to be the number one. You have to know you can get the correct answer with that method. And number 2 is the fastest method. So if you're comfortable with both ways, use the one that's the fastest. And that's why the practicing is so good. So we get to know all these methods and we know what works best for us and for the problem. So for this one, f of x equals 1/10 x minus 2. You can graph functions by replacing the f of x with y. And they're telling you that right there when they say y equals f of x. So this is the same as y equals 1/10 x minus 2. When we have a line that's in this format, it is in slope-intercept form. We write that slope-intercept form as y equals mx plus b. When we have slope-intercept form, the m and the b are constants, or just numbers, plain numbers. The x and y change, and the m and the b stay the same. The m here is our slope, and the b is our y-intercept, always. So in this equation of a line, y equals 1/10 x minus 2, I know that 1/10, 1 over 10 is my slope, and -2 is my y-intercept. And there we go. I don't have to graph it. And when I know -2 is the y-intercept, now I need to put that into an ordered pair form in order to get my correct answer. So when we have an ordered pair, it's always my x value and then my y value. They're in alphabetical order. I know my y value is -2, and the x value for a y-intercept is always going to be 0 because it's saying, and I should have said this at the beginning, I apologize, y-intercept means where the function crosses the y-axis. So this is going to be a very shallow line, and I'm not drawing this to scale, but it's like going to be like a very shallow, very low upward slope to the right line, and it's going to cross at -2. Anywhere on the y-axis, x is 0, always. all y-intercepts, the x is 0. So my coordinate is an x value of 0 and a y value of -2. And that is my answer, B. So if we have this knowledge that y equals mx plus b is the slope-intercept form, and that means that that -2, let's get just that -2, there we go, is my y-intercept, I don't have to take the time to open Desmos or to get my graphing calculator and type in f of x equals 1 divided by 10x minus 2, then graph it, then zoom in. You're probably saying like, but Alyssa, it's only a few seconds, like what, like 10 seconds more, maybe? When you're taking this test, seconds can count. We want as much time as possible for the harder problems that are always waiting for us at the end. This particular module in particular, there's a lot of questions at the beginning that I think most students are going to go through pretty quickly. And then as it gets to the end, there's a couple that are little stinkers. They are rough. So the more time you can give yourself by doing these early questions very efficiently, it helps you and raises your chances of getting those really high, awesome scores. And that's what we want. So here, that y-intercept is 0, -2. Number 9. A producer is creating a video with a length of 70 minutes. The video will consist of segments that are 1 minute long and segments that are 3 minutes long. Which equation represents this situation, where x represents the number of 1 minute segments and y represents the number of 3 minute segments? When we're creating equations with variables, we want to make sure that every single thing in the word problem is being represented and that we're representing it accurately, right? So a good way I find to do that is to kind of think with real numbers. If you're reading this, I know word problems can be problematic for a lot of students. They can, make us go like, what's going on? I get it. So if that is the case for you, something you might try doing is representing this with real numbers. So you might say, okay, in this one, we're talking about someone who's making a video and it's 70 minutes long. Okay. And it's going to have segments that are 1 minute long. And it's going to have segments that are 3 minutes long. How would I know what the total number of minutes would be? So let's put aside the 70. Let's just think in the abstract. If I said, okay, I'm making this film that's a compilation film, and it's going to have 6 segments that are 1 minute long and 10 segments that are 3 minutes long. And someone goes, wait, how long is that total? How would we figure that out? Well, if there are 6 1-minute segments, we're counting 1 minute 6 times. So that's multiplication, 6 times 1. So the total number of minutes for those 1 minute segments would be 6 times 1, or 6. And then the total number for the 3 minute segments would be 10 times 3, because there's 10 segments that are each 3 minutes long. How long in total? 10 times 3. And that would be 30 minutes. And then what would we do to figure out the total length of the film? We would add those together. 6 plus 30 would give us 36 minutes total. So look at what we did here. What was the process when we knew what the numbers were? We took the number of segments, we multiplied by the length of time, the length of the segment, and we did that for both. We took the number of segments times the length, and then when we had them, we added them together, and that gave us our total number. That gave us our total length, our total time. Okay, so that's a real world scenario. Now let's look at our word problem here, and let's do this with the more abstract x and y. Okay, so again, we have 1 minute segments and we have x of them. X represents the number of 1 minute segments. Well, we already said we took the number of segments, we multiplied by the length. All right, so let's do that. The length is 1. We're multiplying by the number of segments, which is x. Okay, then the second one said is y represents the 3 minute segments. Well, in our example, we took the 3 minute and we multiplied by the number, We're going to do that again. So it's 3 minutes. We multiply by the number of segments. That's y. Okay. Then what did we do after we did that? We added them together. So I'm going to add those together. And when I added them together, I got the total length of the film. Okay, so what is the total length of the film? It is 70 minutes. So that's our equation. And when it's a 1, like here 1 times x, we don't have to say the 1 because any number times 1 is just that number, right? That's the identity property. I believe that's the correct term. Identity property of multiplication. Any number times 1 is just itself. And so that's it. It's x plus 3y equals 70. And that is D. And again, I'm not saying that you need to write all this out, that it's necessary for you to write this out in order to get to this equation. This is more of a sort of helping you to visualize what's going on and presenting you with a tool that can be helpful if you are finding a particular problem difficult. If you use real numbers in there and go, if I knew the real number of how many segments it was, what would I do? It can often help us figure out what the algebraic equation is that would apply in any scenario by picking one specific scenario. So again, our answer there is D, x plus 3y equals 70. Number 10. The function f is defined by f of x equals 7x cubed. In the xy plane, the graph of y equals g of x is the result of shifting the graph of y equals f of x down 2 units. Which equation defines function g? They are testing your knowledge of a pattern or several patterns that you can follow when you are translating or moving functions around. And for this, I think it's best to go to Desmos so I can, show you what's what. Let's do that. Right, here we are in Desmos, and I've put in the f of x equals 7x cubed. Now, when we have a function, there's a couple of things that we can do pretty simply with it by just changing it in repeatable ways. So here's the first way. If we want to move this up or down, we need to add or subtract a number on the outside of the main function, like the x cubed in this case. That's sort of our main core function. This is a cubic. X cubed is the heart of the thing. If I were to add or subtract a number outside of that, it's going to put it up or down, and it's going to do it directly. So if I add 5, it's going to move it up 5. Let me zoom out a little bit so we can actually see that happen. All right, so if I go add 5, there it goes. It goes up 5 towards the positive y. If I make this a negative, it's going to go down. So like if I say minus 2, there it goes down 2. And this applies with multiple, kinds of functions, like pretty much all of them. I hate to always say all of them because then someone comes up with an exception. But when you see this on the SAT, this is going to work. This is what they're testing. So like, let's say if it was, x squared. I say, okay, x squared plus 3. Up it goes 3. Like that. If it was even like let's say an absolute value function, I can talk. Like absolute value of x plus 2. Up it goes 2. So you can see this is the same sort of pattern, is working here. Okay, well, what if we wanted to move it? I'm going to get all these back to normal so we can see this. What if I wanted to move it left or right? Well, that goes inside the function, by which I mean, like, put a little parentheses around that x so that cube goes on the outside. And then add or subtract inside it. And this, once it goes inside the parentheses, it's going to be the opposite. So it goes left or right, but the opposite. So if I want it to move to the left, towards the negative x, I need to add something. So we'll say plus 6, and there it goes to the left, 6. If I want it to go to the right, I need to do the opposite. That's towards the positive x, so I need it to be subtracting. Let's go minus 4. There it goes to the right. And I'll show you the same thing here with this like x squared. Let me turn on the x squared again. If I want it to go to the left, I'll put it inside there with the x. And I want to go to the left towards the negative, so I do the opposite. I add plus 1. There it goes to the left. Same with this absolute value of x. I go inside that absolute value. And let me turn it on so you can see it. And okay, I want it to go to the right 10. That's toward the positive 10, so I'll do the opposite. I'll do minus 10. And there it goes to the right. Okay, so that's moving it left or right. Let me get all these back to normal again. There we go. Okay, back to our 7x cubed. And the other two things you can do with it, one is if you give it a negative in front, it's going to flip it upside down. So if I do negative, there it goes, it flips it. Let's put these back on here. If I do negative x squared, it goes down. Negative absolute value, it just flips it, whoop, mirrors it downward. All right, so those are negatives. And the last one on here, this 7 out here is actually the last one. If there is a number in front of it that's multiplying by the function, it's going to affect how wide or narrow it is. So this one, the 7x cubed, is making it more narrow. If I deleted that 7, you're going to see it stretch. See, there it goes, it stretches. So the higher the number, the narrower it gets. You can make it wider by putting a positive number. Some people think, oh, it's put a 7, so a negative 7 will make it narrow. Nope, the negative flips it, but it'll still be just as narrow. The numbers that make it wider are fractions, specifically fractions or decimals, but just parts of a number between 0 and 1. So it would have to be like, say, 2/7. There, made it wider. And again, that's going to work with all of these. So your x squared, put out there and make 5x squared, it becomes narrower. If it was 1/5 x squared, it becomes wider. Here's our absolute value of x. Let's say 8. There it becomes narrower. But if I did 1/8, it becomes wider. Yep, between 0 and 1, those fractions make it wider. Anything greater than 1 makes it narrower. So with that knowledge in mind, let's look at our question again. It says g of x is the result of shifting the graph down 2 units. Well, we've got our 7x cubed, roughly drawn here, and we want to shift it down 2 units. And because I know about my translating, I know that to go up or down, should have drawn the up first, up or down, it is adding or subtracting a number on the outside of the function. And this is down 2 units, and it's direct. So if I want to go down towards the negative y, I need to subtract 2. So to go down 2, subtract 2, and that's it. If I have that knowledge, this is a very fast problem. If I have that knowledge and I can recall it and go, okay, up or down, I want to go down towards the negative, down 2, minus 2 goes on the outside, D is my answer, and on you go. You're on to the next problem. Now, if you don't remember this, can you solve it through graphing? Yes, you can. However, in this case, it's not going to be a difference of just a second or two. I think it's much more time consuming, frankly. So here's how you would do that. You would enter the first one, which is 7x cubed, and then you would need to enter all the options that are provided. So it's g of x equals, let's see, that's 7/2 x to the power of, oops, and see, I made a mistake here. That's my fault. I did not do that on purpose. I'm not trying to make a point. I promise. I just made a boo-boo. Right, 7/2 x cubed. Then g of x is equal to, let's see, 7x to the power of 3/2. 7x to the power of 3/2. Okay. And next one is g of x is equal to 7x cubed plus 2. And then finally, g of x is equal to 7x cubed minus 2. And then finally, I'm looking at the graphs. Okay, I see that the one that moved it down to is the 7x cubed minus 2. Now, things might work in your favor when you're graphing stuff, and maybe it was the A. That was the answer. And you type it in, you graph it, you see it, and you go on your merry way. But sometimes, like in this case, you would have had to type in all 4 of those before you found the correct answer. Again, if you don't remember how to do this translation, is it the end of the world? No, obviously not, because we have this. We have this as a tool, so you can absolutely still get the right answer. But having these other methods at your disposal can save you a lot of time, and that's always a good thing. So there you go. There's our answer to 10. It is D. Number 11, y equals negative 3x, 4x plus y equals 15. The solution to the given system of equations is x, y. What is the value of x? A system of equations can be two lines, it can be a parabola and a line, it can be any kind of combination that you want, really. Just two different equations, and you're trying to find the x and y values that will be true in both of them. The most common type of system of equations you see on the SAT is linear, that is, two lines. Now, to solve a linear system of equations by graphing, you would graph the two lines, and then you'd look for the point where they intersect. And that x, y, whatever those values are, x and y, for that point of intersection is the solution to that system of equations. There are two other common ways that we can solve linear systems of equations, that is, substitution and elimination. Elimination is where we want to add the two equations together, and when we do that, we want either the x's or the y's to cancel out. So you're like, okay, the x's are gone. When we add together, like say, for example, if it's like 2x and negative 2x, those would cancel out, and you're just left with a number of y's and a constant over here, so that way you can solve for y. That's all. The whole idea is always to isolate one of these variables and get it equal to a constant. The other method you can use for this is substitution. And looking at what they provided with us here, that's the method I'm going to use. I think it's a little faster than graphing in this particular case, but is graphing a bad choice? No, it's not. Sometimes I'll be like, it's going to take so much longer to graph it. Be sure you know how to do this. This one I'm going to say, it's not going to take you that much longer. Also, be sure you know how to do this. So for substitution, you want either the x or the y to be isolated. So you pick one of the two given equations in whatever problem it is, and then you manipulate it so either it's x equals blah 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 or it's y equals blah blah blah. Well, here they've already done that, which is why I immediately went to substitution. This right here already is in that form. It already is y equals, and everything else is on the right, negative 3x. I'm like, sweet, that's great. Now, how difficult is it going to be for me to solve for x when I substitute it? And when I say substitute, what I mean is, now that I know that y is equal to negative 3x, wherever there's a y in this second equation, I want to replace that y with negative 3x. And I look at this and I go, wait a minute, 4x plus, when I put negative 3x in here, 4x plus negative 3x, that's just x. Like, okay, substitution, yeah, absolutely. So let's do that. 4x, put in that negative 3x, 4x minus 3x, or 4x plus a negative 3x, same difference, is just x. I don't have to do anything else. I've got my answer. X is 15. And I don't have to solve for y because they're not asking me to. They're just saying, what's the value of x? X is 15. That is C. So again, when you have where they've already solved for an x or a y, take a second and look and see if, it's going to be fairly simple or time-saving to do it by substitution. Also, you look and see if elimination might be a good choice. There's some of those where when you line it up, they present you with like 2 and they're already, like say if it was like 2x plus 3y equals something, and then negative 2x plus y equals something, and you go, hey, wait a minute, it's already set up. Those will cancel out. Something like that. Yeah, when you have that knowledge, that's why I encourage knowing all the different ways. When you have the knowledge of the different methods, you also will know which one is the most comfortable for you. That is, which one you can do correctly and accurately and get the right answer, and then which one is also the fastest of all those comfortable methods. So this one for graphing, you'd look for, you draw your two lines, you look for the point of intersection, and then you would get the x value from that point of intersection, because that is what you need, that x value. And that's it. Either way, you're going to get C, 15. Number 12. Triangle ABC has sides of 35 and has a hypotenuse of 171, and we are not given the third side, the second leg, the third side of this triangle. It says, note figure not drawn to scale. In the right triangle shown, what is the value of sine A? Sine, cosine, and tangent are the three trig identities that you need to know for the SAT. They are universal ratios that people long, long ago calculated and wrote down, and now we have computers that can calculate them and access those ratios, and they can be very helpful. For the SAT, the big thing you need to know is that the sine of a given angle is equal to the length of the opposite leg over the length of the hypotenuse. Cosine is equal to the length of the adjacent leg divided by the length of the hypotenuse, and tangent is equal to the length of the opposite leg over the adjacent leg. You may have seen your math book or your teacher write this as SOHCAHTOA. Running out of room there. SOHCAHTOA. That's for sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. If that's helpful to you, that's great, but this is definitely something you need to memorize. Yes. So when we say opposite and adjacent, what do we mean? If I have a right triangle poorly drawn, and this is my angle right here, the opposite leg, and when we say leg, we mean the two shorter sides that are touching the right angle, that are making the right angle, and the hypotenuse is the longest side, the one that is opposite of the right angle. And that's what opposite means. Opposite is the side, the leg, that the angle is looking at. I like to think of it as, people are sitting at a table. We have several people sitting at a table. And, this person right here, the person that's opposite them on the table, they're looking at them, but they're not touching them. And the person that they're adjacent to, they could conceivably be bumping elbows all night, especially if one's left-handed and one's right-handed. They're bumping elbows as they eat. And then that's their adjacent. The same is true in this triangle. So this angle, the opposite leg is the side that they're looking at, but they're not touching. And the adjacent leg is the one that's bumping elbows with them, the one that's touching that angle. So for this particular triangle, I'm going to erase that. There we go. We want the opposite side divided by the hypotenuse. Well, here is angle A. The opposite side, the opposite leg, its length is 35. And the hypotenuse, that longest side, its length is 171. So that's all it is. It's 35 over 171, which is B. And that's why this knowledge is so important, because if you have that knowledge, you can get this question done very quickly. You can just go, wait, it's just opposite over hypotenuse. That's 35 over 171. B, moving on. And that's what we want. For these questions like this, we want you to be able to recognize very quickly that you don't have to do any math. You can just find the answer, go on about your business, save that time for those more difficult questions that are further along the road, along the line, along the load, the line, the road, it comes together. So in some cases, in some certain problems, they might give you these two sides expecting you to use Pythagorean theorem to figure out this side and then use it to do, your trigonometric identities. It's not the case here, but be aware that that may happen. But here it's just very straightforward. Opposite over hypotenuse, 35 over 171. That's B. Number 13. What is the area in square centimeters of a rectangle with a length of 34 centimeters and a width of 29 centimeters? There's no trick to this one. It is just testing your knowledge of how to find the area of a rectangle. And the area of a rectangle is length times width. And it doesn't really matter which side. If we draw this, if we were to draw a rectangle, it wouldn't really matter which side we called the length and which side we called the width. We could do that. We could reverse it and go that way. It doesn't really matter because we're just multiplying them together, so the order doesn't matter. But here, the 34, the longer side, so I'm going to call that my length. That's the longer side of the rectangle I've drawn. That's 34. And my width is 29, and these are both centimeters. So when I multiply these together, I will get centimeters squared, or square centimeters. And that's the only other thing I would advise you to look out for in these kind of problems, is make sure that they haven't thrown in a sneaky unit conversion in there. And we double check. No, that's centimeters, and they want the area in square centimeters. Hey, it's all good. So we don't have to worry about that, but check for that, because it's not beyond them. They could absolutely do that. Put them so that you're finding square centimeters, and then they want it in square meters, something like that. But here it's just very straightforward. Length times width. Our length is 34. Our width is 29. And when we multiply those together, we get 986 square centimeters. But they've already said it's in square centimeters, so we don't have to worry about including square centimeters or centimeters squared in our answer. It is just a right-in answer of 986. And that's it. That's your answer. Number 14. If x divided by y equals 4 and 24x divided by ny equals 4, what is the value of n? I see the way this is going to go down. This is one of those problems. It's kind of like I can see all the students out there looking at this a certain way and getting it wrong. Be careful. Be very, very careful. Because here's what I predict is going to happen. I predict people are going to see that 24 over n, and they're going to forget about this x and y, and they're going to see that it equals 4, and they're going to go, n is 6, because 24 divided by n is, by 6 is 4. 24 divided by n, in this case 6. 24 divided by 6 is 4. I've got my answer. No, you just got it wrong. That's what I'm guessing a lot of students are going to do on this one. Let's look at what's actually happening, and then we can solve for n. So x over y is equal to 4. Okay, and then separately, actually I'm going to use a different color. Ooh, be very fancy. 24x over ny is also equal to 4. So it's the same. Nothing has changed. There's a couple of ways we can look at this. We can look at this kind of algebraically, or more sort of like, I'd say, like a logic problem. So let's look at it through the logic problem lens first, just because, why not? All right, so nothing has changed, right? X over y equaling 4, and now 24x over ny equaling 4. Nothing changed. It's exactly the same result. So x over y, I'll change this to erase a partial stroke. We could view this as 24 over n times x over y, right? And we could even, oh goodness, let me highlight things in peace, whiteboard. Nope, it's not going to let me do it. It's not going to let me draw and highlight things. Oh, there it goes. There, now it's happy. Okay, I can move this over. There we go, so that it's 24 over n times x over y. That's the same thing. So x over y equaled 4, and then I multiplied it by something that didn't change it. What can we multiply a number by that won't change it? The only thing that we can multiply it by that will not change it is 1. 24 over n must be equal to 1, because multiplying it times x over y didn't change anything. It still stayed 4. So 24 divided by what equals 1? That's 24. 24 divided by 24. So n must be 24. Now that's what I said, sort of like the logic problem way of looking at this. Well, now let's look at it. We're going to get the same answer. Remember, our answer we're going for is 24. Let's look at it algebraically. And I'm showing you both of these ways because I want you to do what makes the most sense. I want you to be able to understand this problem, and you're not going to see this exact problem on the SAT, of course not, but you might see things that use similar strategies, principles, and you'll have these sort of skills in your head, and you'll know what works best for you. Okay, so let's look at it again from a different perspective, a certain point of view. X over y equals 4, then 24x over ny equals 4. Now I'm going to do the same thing that I did, and I'm going to say 24 over n times x over y equals 4. And I'm going to view it as like a substitution. Like I've just been given two equations, a system of equations, and I'm trying to solve. But it's a little different than our normal ones. But I know that x over y equals 4, so I'm going to substitute 4 right there for x over y. So 24n times 4 equals 4. Now I want to get 24n by itself, so I'm going to divide both sides by 4, or because we already have a fraction here and it's going to look a little odd, I'm going to say I'm going to multiply both sides by 1/4. That is the same difference as dividing by 4. So on the left, I'm going to multiply that 1/4 times 4, because commutative property of multiplication means I can change the order. So 1/4 times 4 is 1, and I'm just left with 24 over n times 1, or 24 over n. And on the right, 4 times 1/4 is 1. So now I have 24n equals 1. To solve for n, I needed to get it out of that denominator. So I'm going to multiply both sides by n. On the left, those n's cancel out, and I just have 24. And on the right, 1 times n is just 1n, or n. And there you go. And that's the more strictly algebraic way of looking at it. So either way you look at it, as either an algebra problem or a mathematically inclined logic problem, you're going to get to that same answer, that n is 24. And yeah, I just can see a lot of students, especially because this is a write-in question, not a multiple choice question. I see a lot of people just glancing at this and going 24 over n equals 4, 24 divided by 6, n must be 6. I can see that happening. Be careful with these. Don't make that mistake. Go through them. Go through it algebraically or logically, whichever you prefer. That way you'll get to 24. Number 15. A bowl contains 20 ounces of water. When the bowl is uncovered, the amount of water in the bowl decreases by 1 ounce every 4 days. If 9 ounces of water remain in this bowl, for how many days has it been uncovered? You could put together an algebraic equation for this. I think it's easier just to kind of, I hate to say like count on your fingers, but it's that kind of thing where we just count it out. I think that's just as effective and probably a little more effective, honestly. So let's look at this. Let's separate this 4 days first. Let's not look at that just now. We know it's decreasing by 1 ounce every cycle. Okay, every cycle that happens, 1 ounce decreases. It decreases by 1 ounce, I should say. So it starts at 20 ounces, and after one cycle, it is down to 19 ounces. It has lost 1. And then another cycle happens, and it's down to 18. So 2 cycles brings it down to 18. And the reason I'm drawing it out like this is because sometimes when we're talking about counting cycles and things, you want to make sure that you're not just blindly subtracting the number and assuming that's what it is, by which I mean sometimes the first cycle it would stay at 20, and so that counts as a cycle, and then when you subtract 1 you're actually on the second cycle, that kind of thing. It depends on the word problem, it depends on the scenario, so I find it helpful to kind of visualize it and write it down, and then you're sure that we're doing the right thing. So okay, so that's 1 cycle, and that's the second cycle. So in this case, it is just subtracting. So when we get all the way down to 9 ounces remaining, how many cycles have passed? Well, this would be 20 minus the number of cycles. I'm going to just call that C. So 20 minus the number of cycles is going to equal 9. and that's going to be 11. We can view that, we can actually do the math, but I'm guessing a lot of you, when you just look at this and go 20 minus what equals 9, you're going to know that that's 11. And no shade if you didn't know that offhand, that's fine. I'm just saying that, like, if you do, you don't have to go through the steps. You don't have to go through the steps of doing the algebra solving if you don't, if you have that knowledge ahead of time. So let me just change over here. But if you would like to go through the steps, that's perfectly fine too. You do what you need to do to get the answer right. That is the most important thing. Not how other people do it, but how you're going to get the answer right. So if 20 minus c equals 9, I can isolate that c by subtracting 20 from both sides. And I get negative c equals negative 11. And to get rid of that negative, I'm going to multiply both sides by negative 1. On the left, I get c, and negative 11 times negative 1 is just 11. All right, so c is 11, so the number of cycles is 11 cycles to get it down to 9. And now we can look at how long a cycle is. A cycle is 4 days long. So 11 cycles times 4 days, because that's what we want to know, how many days. That is 44. Now let me move this separate over there. Wait, so 44, and that is D. D is my answer. Number 16. If 9 times 4 minus 3x plus 2 equals 8 times 4 minus 3x plus 18, what is the value of 4 minus 3x? This kind of problem where they don't ask you to solve for x, but instead ask you to solve for something unusual, like in this case, 4 minus 3x, always, always, always look at the original problem and see if there's a way that you can manipulate it to just get a 4 minus 3x or whatever funky combination it might be by itself. 9 times out of 10, if not more often, you will be able to do so. Because what's the alternative here? The alternative would be that you would have to distribute all this. Ugh, right? Ugh, we don't want to do that. We don't want to do that. That's going to take so much time. 9 times 4, 9 times negative 3x. 8 times 4, 8 times negative 3x. Then combining like terms over here, combining like terms over there, solving for everything, solving for x, then plugging it back into 4 minus 3x to get our answer. Is that possible? Absolutely. It is. I do not recommend it. Here is what I want you to do. Again, anytime you see this thing where they're asking for something odd, here they're asking for 4 minus 3x. That's odd, right? And we look at this and we go, wait a minute, we got these 4 minus 3x's. What if you treat 4 minus 3x like a unit, like it's its own variable? Then what will we have? On the left, we have 9 of this unit plus 2 equals 8 of this unit plus 18. So let's try moving this over here and then the number over there. Essentially, we're turning it into the same thing as if this were, let's say, 9, and since it's a unit, I'm going to call it U. 9 of the unit plus 2 equals 8 of the unit plus 18. Now that's a much more simple problem to solve, isn't it? We don't have to distribute, we don't have to do anything. And we would just go, okay, I want to move that 8u, I want to get all those u's on one side. So I'm going to subtract 8u from both sides. And then on the left, I would just have a single u plus 2 equals 18. Those cancel out, just left with 18. And then I'll go, okay, I'm going to subtract that 2, undo that adding of 2 to get rid of that. And then on the left, I just have u, and on the right, 18 minus 2 is 16. I'm going to put that up there on the left. Now, let's do that same math, but with the 4 minus 3x in there, and we're going to get the same thing. show you what I mean. So here I have 9 4 minus 3x's on the left, and on the right I have 8 4 minus 3x's. So I'm going to subtract 8 4 minus 3x's from both sides. So on the left, 9 4 minus 3x's minus 8 4 minus 3x's just leaves a single 4 minus 3x. That plus 2 stays around, and on the right, we just have that 18 because those canceled out. Same sort of thing. 2 is being added to the 4 minus 3x. I want to undo that, so I'm going to subtract 2 from both sides, and I get that 4 minus 3x. Those have canceled out. And on the right, 18 minus 2 is 16. And that's it. That's my answer. It is D, 16. One other way that you could solve this, which I don't recommend, but you could try each of these numbers in this top equation, and once you get one that makes it true, that makes it a true statement when you do the math, you could then take that number and plug it into 4 minus 3x, and that would get you your solution. Again, that's really time consuming. Yeah, even if you put this in Desmos, like even if you were trying to put it in Desmos and do it that way, it just, no. Honestly, I think this is, I like to tell you which way I think is going to be the fastest way, and I think this is the fastest way in this particular problem. If you treat it as a unit, like I just did, then it becomes much more straightforward and gets you to your answer, D, 16. Number 17. A certain township consists of a 5-hectare industrial park and a 24-hectare neighborhood. The total number of trees in the township is 4,529. The equation of 5x plus 24y equals 4,529 represents this situation. Which of the following is the best interpretation of x in this context? For these kind of problems, I do not like looking at this first. I like to read the word problem again and make up my own mind and then look for the answer that matches. I don't always give that advice. For some of them, I say it's helpful to look at the answers first. With this kind, I just feel it can be a little bit confusing sometimes. So let's just focus on the word problem and see if we can come up with our own idea as to what these variables represent. Okay, so there's a 5-hectare industrial park. So I'm going to just do, say, 1, 2, 3, just so we can visualize this. 5 hectares. And then there's a 24-hectare neighborhood. So that's going to be like, let's see, boom, boom, boom. There we go, 24. 6 times 4. Okay, I know they're not square. Just go with me. So the total number of trees is 4,529. So add them all together, we get 4,529. And we have this equation, 5 times x plus 24 times y equals 4,529. So I've got these 5 hectares up here, and I've got a 5 there, and I have 24 hectares here, 24 there, and this math that I'm doing equals 4,529, which I've been told is the number of trees. All right, so 5 times a number plus 24 times a number, total number of trees. To me, this sounds like it's the number of trees in each hectare. Let's say there's 6 trees on each of these. How would I find how many trees are in this area? It would be 6 times 5. That would be represented by this, 5 times the number of trees. Same down here. If I had, 15 in each of these, 15 trees in each one, I said, okay, how many trees do I have total? It would be 24 times 15. My y there would be 15, the number of trees in each hectare. And since we're talking about x, that is this one right here, 5 times x, it would be up here. It would be the number of trees in each hectare in the 5-hectare industrial park. So the number of trees per hectare in the industrial park. That's my answer. Let's look at our options. A, the average number of trees per hectare in the industrial park. That looks like it, but let's look at the rest. B, the average number of trees per hectare in the neighborhood. Nope, that's going to be Y. C, the total number of trees in the industrial park. No, that's 5X. And the total number of trees in the neighborhood. Nope, that is 24Y. Our intuition there, our first feeling about A holds up. It is A. That is my answer. Number 18. Which expression is equivalent to a to the power of 11/12 where a is greater than 0? There are two different mathematical principles, and they want you to be familiar with for this one. The first is what a fractional exponent is, what it means, how we convert it to a root. We need to know this because we look here, all 4 of our possible answers are roots. So here is our rule. If I had x to the power of a over b, it is the same as the b root of x to the power of a. So for example, x to the power of 1/2 would be the square root, which we don't usually write the 2, but we could write if we wanted, the square root of x to the power of 1, or just the square root of x. That to me is the way that I always remember which one goes where, because I know x to the power of 1/2 is a square root. So the 2 is outside for that square root. We always have to come up with ways to remember these sort of things. This one's mine. You know, if another way works for you, like put it in the comments below. Let me know what your method is for remembering this one. I'm always up for learning new mnemonic devices for things. So we have our a to the power of 11/12. So we go, okay, let's convert it. I know that b goes out there. It's the 12th root of a to the power of 11. And I've got my answer, and I go and I look over here and oh no, that is not an option. What is going on? Well, let's look at these options and let's see what happens if we convert them this way. Let's see what we get for these 4. Let's see if any of them are close to what we know here of these two, what we've got going on. Let's see what's going on here. All right, so first we have a, which is the 12th root of a to the power of 132. That would convert back to a to the power of 132 over 12. Okay. Zoom out a little bit. Let's get all these on the same page. Okay, then our next one is the 144th root of a to the power of 132, which would be a to the power of 132 over 144. Okay. Next one is the 121st root of a to the power of 132. And that would be a to the power of 132 over 121. And then our last one, let me get a different color. Ooh, let's go purple. Our last one is the 11th root of a to the power of 132. So that is going to be a to the power of 132 over 11. And one of these is equivalent to a to the power of 11/12. You go, okay. And a little side note here, if you were doing this problem and you jumped straight to here and you went, wait a minute, all these numbers are really different from a to the power of 11/12, even if I do this, it's not going to end up the same. That's great. If you were able to jump that step, if you didn't realize that, if you're doing this, do not beat yourself up about that one, honestly. Because I think the logical thing is to think when you just see roots, not really to look at the details of those roots, but immediately do your conversion and then look for the answer and go, wait a minute, something ain't right. And then you have to come back to this step where you're, converting them all and then trying to see what's going on. Okay, so now we have our 4 fractional exponents, and we need to see which of these is equivalent to a to the power of 11/12. So I'm going to get rid of my roots. So we just have our 4 little ones here. And I'm going to make them all line up here. Nice and pretty. There it goes. I got there in the end. It somehow worked. All right, there are my 4. which of these could possibly be equal to a to the power of 11 twelfths? So really what I'm saying is, which of these fractions is equal to 11 twelfths? We have this 11 twelfths fraction, because the base is not changing. It's a in all of those. So that's not going to change. So I just need to know which of these 4 fractions is equivalent to 11 twelfths. Well, let's look at it. Is 11 twelfths the same as 132 twelfths? Does 11 twelfths equal 132 twelfths? No, there's no way to get from 11 twelfths to 132 twelfths. We could not, or the other way around, either way. So I couldn't multiply 11 twelfths by anything to get to 132 twelfths. And I couldn't simplify this to get to 11 twelfths. And I know that without doing any math, because when you simplify both the bottom and the top, the numerator and the denominator, both of those things, numerator being the top, denominator being the bottom, both of them will get smaller if we're simplifying. And that 12 can't get any smaller because it has to be 12. Because 11 twelfths over here on the left is as simple as it gets. It can't be simplified. So 12 on the bottom has to be the smallest it can be. No. If I simplified this 132 twelfths, the 12 would get smaller, so that's not going to work. So that one is out. What about the next one? 132 over 144. Could that simplify to get me to 11 twelfths? That one looks like it could be. So let's say 11 times what? We can either go either way. We can try to simplify 132 over 144, or we can ask ourselves 11 times what equals 132, and 11 times what equals 144. I think this might be a little easier if you have experience with times tables, if you have those memorized. You might go, wait a minute, I know these from the 12 timetables. 12 times 12 is 144, and 11 times 12 is 132. Hey, 12 over 12 is 1. So 11 twelfths times 1, we haven't changed it. So this is true. 11 twelfths is equal to 132 over 144. So, okay, I think we found our answer. But just to prove it to y'all, let's go through and let me do those other ones. So is 11 twelfths equal to 132 elevenths? Nope, same sort of thing. There's no way this could be the same as this. If I was to simplify it, this 11 on the bottom cannot simplify to 12. That's impossible. And it would have to be, it's already smaller than 12, so it can't get smaller to become 12. Yeah, and the 132 would have to get smaller to be 11. No, that's not possible. That one is out. And then the last one, 132 over 121. This is 11 times 12 gets you to 132, but 12 does not go into 121 evenly. 121 is actually 11 squared. So it's almost like what they did is they did 11 twelfths times, not almost, this is what they did. They did 11 twelfths times 12 elevenths to get to 132 over 121. And multiplying it by the reciprocal does not leave something unchanged. For example, if I multiplied 5 times its reciprocal, 1/5, I would get 1. You know, it doesn't leave the 5 unchanged. So it would have to be multiplied by 1. So it either need to be 11 over 11 or 12 over 12 or any other number over itself besides 0. That would leave it unchanged, and that's not what's happening here. So this one is out as well. Now I will say, if you didn't want to do that math, there is a sort of little logic way that you could look at these 4 contenders. Like let's say, and again, we've established that it is B, 132, the 144th root of a to the 132nd power, which is the same as a to the power of 132 over 144. But if you didn't want to go through that math and we were kind of back at this stage, you could look at these logically and go, well, 11 twelfths, whatever fraction has to be equivalent to that, has to have a smaller number on top and a bigger number on the bottom. And the only fraction here that fits that is that one. All the other three have the smaller number on the bottom. So it's impossible for any of those to be equal to 11/12, where the numerator is smaller than the denominator. Now, I did not say that first because that's how you could solve this problem, but it's not how you're going to solve every problem that's like this. And I have seen this type of problem before where they have a fractional exponent and then a bunch of roots that are not direct correlations with it, that they have to be changed, that you have to multiply that fraction by something to get to that root. I've seen this before. I cannot recall if they use this same sort of setup where there's only one that's even possible before you do any math. It's unlikely. It's unlikely that you'll get that. Don't count on it. In this case, yes, it works, but please know how to use the other method. You know, when you get those little gifts that they give you, like, hey, wait a minute, I don't have to do math. I can just go, hey, this is the only one where the denominator is bigger than the numerator. It must be that one. It is. That's great. But don't bet on it. Know how to do the math. All right, B is my answer. Number 19. The dot plots represent the distributions of values in data sets A and B. Which of the following statements must be true? The median of data set A is equal to the median of data set B, or the standard deviation of data set A is equal to the standard deviation of data set B. And then we have our options, and it is important to look at these. It's 1 only, 2 and only, 1 and 2, neither 1 nor 2. Okay, so some combination of these, and they're asking about median and standard deviation. Median is something that you are called upon at times to calculate on the SAT. However, standard deviation isn't. That is, you do need to recognize what makes something have a low or high standard deviation when you're looking at a data set, but you do not have to know how to calculate it. I know in your math classes you may have had to do that. You do not have to do that here. All right, so let's really look at this data set. Let's zoom in. Okay, we have those two things. We have median and we have standard deviation. Let's start with the median first. Median is the middle value in a data set. Just if you list the numbers, if you were to list them out left to right and they're in a list, like what is the number that's right smack dab in the middle? And that happens when we have an odd number of values in the data set. If it's even, you take the two numbers that are physically in the middle and you average them together. So like let's say, I had 1, 10, 13, 50, and 100. That's going to get cropped. There we go. There are 5 numbers. The number that is physically in the middle is 13. It's in the middle. There's 2 numbers on either side. 13 is my median. If there had been one more number in this data set, like 101, then we would say, okay, there is not a single number right in the middle. The exact middle point would be right here, 3 numbers on left and right. So instead, we take the numbers that are in the middle, closest to that exact middle point, 13 and 50, and we would average them, and that would give us our median. So it's the number in the middle, like that game Monkey in the Middle. I don't know if you ever played that. That's a very old game. Don't know why they called it that. I don't really care for that name. Anyway, I digress. Okay, so the median is going to be the number that's physically in the middle. Now we can count the number of values that are in this, but we can also just kind of look at it because both of these data sets are symmetrical. Here we have this doom, 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 doom. That's symmetrical, and then foom, 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 foom. That's symmetrical. I know the lines I drew were not symmetrical, but you get the idea. So it's going to be what's in the middle. We don't have to really worry about counting how many values are. They don't tell us how many values there are. Sometimes they will. They'll say like this data set has, blah, 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 has 15 values, has 22 values, whatever. Here they don't, but we don't need to count them. We just look, okay, it's symmetrical, so the ones that are right here in the middle, that's going to be my median. Data set A, the median is going to be 13. The middle number is right there in the middle, it's 13. So my median for data set A is 13. And how about data set B? Well, same thing. That middle value, the one right in the middle, there's the same number of values on either side. It's also 13. So our first statement that the median of data set A is equal to the median of data set B, yes, that must be true. So I know already that B is not the correct answer because B says 2 only. I also know that D is not the correct answer because it says neither 1 nor 2, and 1 is true. So my only possible answers are A and C. So I need to see if 2 is possible, because if it is possible, then it will be C is my answer. If it's not possible, A will be my answer. Right, so let's move on to the standard deviation. Now again, I don't have to calculate the standard deviation on the SAT. I just need to recognize it. Standard deviation is how far things deviate, or how far away they go from the center. So like, let's say there is a path and you are walking on the path. And if you stayed on this path, you are not deviating from the path. But if you went like this, like that, you would be deviating from that path. And the further you went, the more they'd say, wow, you really deviated from that path. Whereas if you stayed right on it, or even if you just went a little bit off, you didn't deviate that much. You deviated a little, but not that much. So the lower the number of deviation is, the closer you were to the path would be a lower number of deviation. Now in data sets, that path is our mean or our average. So what's the average going to be? For that, you say, oh, well, I need to add up all the values. We really don't. The average is going to be like what's right in the middle. It's like, let's think of this with a smaller data set so I can really show you what I'm saying here and why we can determine how these means would compare and then the standard deviations would compare. Let's say I have two numbers. Just start with 2 so we can really see what I'm trying to explain here. And I wanted to find the average of these two numbers, the mean. I would add them together, 5 plus 5, then I divide by 2. Because there are two values in this data set. 5 plus 5 is 10, divided by 2 is 5. So my mean or average is 5. What if I went down 1 for this number and then up 1 for this number? 4 plus 6 is 10, divided by 2, I get 5. I do it again. Down 1, up 1. 3 plus 7 is 10, divided by 2 is 5. So when the numbers are moving apart from that central line they're the same distance, the mean doesn't change. Okay? The mean's going to stay the same. So that's why when I'm looking at these, we're going like, okay, they're going to have the same mean because they have the same numbers balanced on either side of this central line of 13. So as long as you're going the same distance from that beginning, so that's what's happening in both of these. So let's say they started that all these numbers had been 13, like all the data sets had been 13. And then one goes down by 1, one goes up by 1. Another one goes down by 1, another one goes up by 1. Then this one goes down by 2, up by 2, down by 2, up by 2, down by 2, down up by 2, down by 3, up by 3. So that mean is going to be 13. It's balanced around that central point. Same thing here. It's the same thing happening. Let's say everything started at 13. Then it went down by 1, up by 1, down by 1, up by 1. Then down by 2, up by 2, down by 2, up by 2. And it's balanced. We have the same numbers on either side. Down by 3, up by 3. So they both are going to have this same mean of 13. I don't have to add all those numbers up. It's balanced. The number in the middle is going to be the mean. It's just one of those little factoids. They don't really explain that, I don't think, in most math classes. But it's true, and that fact helps you on the SAT. Okay, so they both have the same mean. They both have this same path. Are they each sticking as closely to the path? No, they are not. Look at this first one. We have 3 that are on the path, and we can even kind of view that. Let's clean this up a little bit. Let's say this is A. And I've got 3 points that are on the path. I got 1, 2, 3 points that are on the path. And then I've got 2 points that are a little higher. And I got 2 points that are a little lower. Then I have 4 points that are a little further away. And 4 points that are a little further away here. and then just 1 point. Boom, boom, like that. So there's more of a concentration here, in the center. Definitely more than in data set B. In data set B, I think I'm going to just let's put him over here. This is data set B going on that path. We've got just 1 point in the middle, and then just 2 that are close, and then 4 that are further away, and then 2 that are further still. So they've got more that are further away, fewer that are on the path. So those standard deviations, that number that indicates how closely the data is following the path, is following the mean, they're going to be different. Again, we don't have to know how to calculate them. We just have to recognize that it's different. A is going to have a lower standard deviation. More numbers are on the path. More are closer to it. There's only 1 outlier on the top end on both sides. This one, and it has 3 that are in the middle. This one only has 1 that's on the path, and it has 2 outliers at the top and the bottom. So it has a higher standard deviation. It's further from the mean. And you can tell this by looking at the graphs as well. You can see that. So like here, you can see there's more closer in the middle, and there's fewer here because you got that 1 difference. The standard deviations are not the same. So this is not a must be true. C is out. Only 1 is true. That is my answer. A, 1 only. Number 20. A circle has center O and points R and S lie on the circle. In triangle ORS, the measure of angle ROS is 88 degrees. What is the measure of angle RSO in degrees? Disregard the degree symbol when entering your answer. I always like to draw things out. It helps me get them. There we go. A little bit better of a circle. It helps me get an idea of where everything is and make sure I'm not making any careless errors. All right, I have a circle and its center is O. Points R and S lie on the circle. And it doesn't really matter if I do this exactly right, if I draw it to scale. It's just to really make sure I'm representing things in my own head, that I've got it straight. Okay, so R and S are on the circle. And we're told there's a triangle ORS. So we need to connect these 3 points. All right, there's our triangle. Those lines are so bad. Let me do actual straight lines using the straight line tool. Woo, I can do tech. All right, so triangle ORS, the measure of angle ROS, this one right here, is 88 degrees. Okay. What is the measure of angle RSO in degrees? So this is our X, the one we are trying to figure out. The fact they're wanting you to recognize is that this has created an isosceles triangle. Why? How do I know that this is an isosceles triangle? Specifically, it's these 2 sides are the same. I know they're the same because this is the center and these 2 points are on the circle, which means OR and OS are both radii of a circle. And whichever direction I go around the circle, the radius is always, always, always the same length. So those 2 are the same. Now, what is a fact that is a good fact and one we should know about an isosceles triangle? I'm going to make this a little more clearly an isosceles and not an equilateral. There we go. In an isosceles triangle, when we have those 2 sides that are the same, the 2, and it's set up like this, if we look at it in this direction, where the 2 congruent sides are left and right, and we have that third oddball side on the bottom, in that scenario, the 2 bottom angles are also congruent. That's how it works. Now this triangle right here has been rotated, so it's kind of in a different orientation, but we need to make sure we're looking at it's the angle between the 2 congruent sides that is the oddball out. The other 2 angles are the same. So this 88 degrees, it's right here in between the 2 congruent sides. So it is the oddball out. And these 2 here at the bottom are going to be the same. Well, now we use our other knowledge of a triangle that those three angles must add up to 180 degrees. So here I have 88 degrees is one of them. Then I have that other angle, which I called x. And then our third angle, it's congruent to that other base angle. So I'm going to call it x also. So 88 plus x is going to equal the total number of degrees in a triangle, which is 180. So I combine these like terms to be 2x. So 88 plus 2x is equal to 180. Now to solve for x, I need to undo what's been done. So x has been multiplied by 2 and then added. 88 has been added to it. I'm going to undo that in reverse order. First, I undo the addition of 88 by subtracting 88 from both sides. And I get that 2x is equal to, let me scroll out and move up because I always run out of room because I write too big. It is going to be equal to 92. That is our 2x equals 92. Then I'm going to undo that multiplying by 2 by dividing by 2. That's the opposite. So I get that x is equal to 92 divided by 2, or 46. That is my value of x. So RSO is 46 degrees, and they're telling us disregard the degree symbol when we enter our answer, so that's just it, 46, and we have our answer. Number 21, the regular price of a shirt at a store is $11.70. The sale price of the shirt is 80% less than the regular price, and the sale price is 30% greater than the store's cost for the shirt. What was the store's cost in dollars for the shirt? Disregard the dollar sign when entering your answer. For example, if your answer is $4.97, enter 4.97. Okay, so our given piece of information is that the regular price of the shirt is $11.70, and I'm going to disregard the dollar sign too and just write it in decimal form. We need to get to the store's cost, but this is going to be a two-step process. First, we have to figure out the sale price, because they tell us how to calculate the sale price relative to the regular price. And then the goal is to get here to the cost. And the cost, they tell us how it's related to the sale. So we have to do it step by step. First one, let's figure out the sale price. The sale price of the shirt is 80% less than the regular price. With percentages are just fractions. So 80% is the same as 0.80 or 80 over 100. Either way. So there's always like more than one way to look at this and to do it. Okay, so sale price is. When we have sale price is, we're setting up an equation. The is the equal sign. I can't think of any exceptions to that. So our sale price is 80% less than the regular price. So the two ways that you could look at it as, this is the regular price minus 80% of the regular price, or 80.80 times the regular price. That's one way you can look at it. Or you could view it as, if it's 80% less than the regular price is 100%. And if I'm taking 80% away from that, that would be 20%. So I'm going to view it as it's 20% of the regular price. And looking at it this way and getting to this, you can see here it's essentially, not essentially, it is the same thing, because here it's like one regular price minus 0.80 regular prices. 1 minus 0.80 regular prices gives you 0.20 regular prices. So see, same difference. It's just how it makes sense to you to put it so that you don't make mistakes. That's the goal. Use the method that makes the most sense to you, that you can do consistently, and you know you're not going to make a mistake when you do it. If that's a little different than the way someone else does it, so be it. It's fine. It's your test. Who cares if someone else does it a different way? Me, I tend to think of things in this way. So I generally go straight to the 0.20 times the regular price, and that's going to be my sale price. Now I'm told that the regular price was $11.70. So when I multiply 0.20 times 1170, and yes, here's one further way you can look at it at this point. 0.20 or 20% is the same as 1/5. So you could say, what's 1/5 of 1170? Or 1170 divided by 5. That's another way you want to do it. And that's the way I'd do it if you're trying to do it without using a calculator. Let's see. As I said that I'm trying to, when you talk about one thing and do math the other time, it's like two parts of your brain fighting each other. All right, so I get that my sale price is $234. And I'm often double checking as I go because I know when you're talking about one thing and doing math at the same time, you can make mistakes. It's very easy to do. All right, so the sale price is $234. Okay, I have my next step in the puzzle, in the chain. All right. Now I need to get from the sale price to the cost. What? And it says, because that's our goal, what was the store's cost? All right, what's the information I have? And the sale price is, there's that is again, 30% greater than the store's cost. All right, so the sale price is 30% greater than the cost. So it's the cost plus 30% of the cost. And so you could add those together and say 1 cost plus 0.30 costs is 1.3 costs. That's odd to think of it that way, but that's what it is. And we know that this is true because if we look at it the other way, as saying the original cost is 100% of that cost price, and then we're adding another 30% of that cost. That is 130% or 1.3. Ding, ding, ding. Right, so we know that the sale price is 2.34. So 2.34 equals 1.3 times the cost. So I'm going to divide both sides by 1.3. And no, this isn't something that I would do on my own. I would use a calculator. It's a little that at this point when you got decimals involved and like, yeah, that's going to be easier for me. I'm not as well versed in multiples of 13. Let's go that way. So 2.34 divided by 1.3 is 1.8 or $1.80. And that is my cost. $1.80 is the cost. And so you can enter this as such. You can enter it as 1.8, 1.80. This also is a fraction, so they will accept the improper fraction 9/5. The only thing they would not accept, the only one that would count wrong, is if you did it as 1 4/5. Don't do that because then it looks like 14/5 to the computer. They do not accept mixed numbers on the SAT when it is a student-produced response question. So 1.8, 1.80, 9/5, $1.80. That's our answer. Number 22. A cube has an edge length of 68 inches. Okay, so I'm going to start. Got my cube here. I'm going to draw it out. And sometimes I read the whole thing, but this one I'm drawing it as I go. Okay, so I've got a cube with edge length of 68. And because it's a cube, I know that every edge is going to be 68. Okay, a solid sphere with a radius of 34 inches is inside the cube, such that the sphere touches the center of each face of the cube. Okay, so let's draw this. Oh, let's see, it's a wireframe, so we're going to see that it's a solid sphere that's inside. Oh, no, no, no. Erase the partial stroke, get that there. There we go. And my only little, I want this to be realistic, darn it. I want it to look like it actually is in there. There we go. Okay, I'm pretty happy with that. Okay, so there is a solid sphere that's inside. There we go. There's a solid sphere that's inside this wire cube that I've drawn. And it has a radius of 34 inches. To the nearest cubic inch, what is the volume of the space in the cube not taken up by the sphere? So the sphere is touching at each of these points. The sphere is touching inside this cube, front, back, in the front here and in the back, it's touching. So what we need to do is we need to take the volume of the cube and we need to subtract the volume of the sphere. And that will give us the volume of the space that is not taken up by the sphere. So what are our two formulas for volume? Well, the formula for volume of a cube is side times side times side, or side cubed. And the formula for the volume of a sphere, this is the oddball. The cube is pretty straightforward. And then the sphere is 4/3 pi r cubed. And anytime that pi gets involved, then I want to look at my options over here, what my answers are going to be, to see if I need to leave it in terms of pi or if I'm going to be multiplying it out. And none of these have pi in the answer. So I'm going to be using the pi button most likely on my calculator, or I could use 3.14. Is it 159? 3.14 is the most common one, but yeah, I always have to kind of look that one up. I tend to forget what it is beyond that point. But using the pi button on your calculator is the best, I think, way to do it in these problems. But we're going to be using that pi button to get an estimate to the nearest cubic inch. That's what they're requesting, to the nearest cubic inch. And so at this point, we just need to make sure we are inserting the correct numbers and that we're doing this math correctly. So first, volume of the cube. So that's s cubed. And we're subtracting volume of the sphere, which is 4/3 pi r cubed. S cubed, we are told each edge length, each side is 68. So 68 cubed minus, I'm going to put this in parentheses to make sure all this stays together, 4/3 times pi, and we are told the radius is 34 inches, which is nice. They didn't have to tell us that. We could have figured that out on our own, because like if you view this like it's a hollow sphere, so you can see the radius inside it, then that radius, it's touching both sides. So it's going to be half the width of the cube. The cube is 68. Half of 68 is 34. So they've told us that. I should have written divided by 2 equals 34. Shame on me. So it's half of it is 34. But they told us it's 34. That's just a piece of extra information in case you get a problem where they don't tell you what the radius is in this solution. I would not put it past them. So the radius is 34. And this, my friends, is when the calculator comes out in force. So 68 cubed is going to be 300. And I'm taking up so much room that I can see my next problem there. Let's move that out of the way. 68 cubed is going to be 314,432. And my 4/3 pi 34 cubed, I'm going to do the 34 cubed first. I'm just doing this the old-fashioned way. I'm not using parentheses or anything. I'm just doing them so I can write the numbers here for you. 34 cubed is 39,304. If you multiply that by 4/3, you're going to get 52,405.3 repeating. And then if we multiply that by pi, we get approximately 164,636.21. Okay, now honestly, I'm really surprised that this number is not up there as one of the options. I would have expected them to put one of those two, either the 314,432 or the 164,636.21, but they didn't, which is nice, but I'm surprised they didn't. I'm just saying that. Okay, when we subtract these, we are going to get our answer, and that is 149,795.79. Round that to the nearest inch, and it becomes 149,796. And that is there is our answer. Yeah, just make sure we know our volumes. They do provide formulas on the SAT, but I like to view those formulas that they give us there as reminders if we forget, or if we're get stressed on the day and we're like, oh, I know that. Look at the formulas. But if you know them, it saves you a little extra time not having to look it up and look at the reference. Time is always great on the SAT. All right, so that is 22. A is our answer. Okay, I'm going to scoot these over a little bit so that have a little more room again. Number 23. Y equals 6x plus 18. One of the equations in a system of two linear equations is given. The system has no solution. Which equation could be the second equation in the system? All right, so two things they are testing here. They are testing your knowledge of how linear equations relate to each other, and then if you can identify the slope in these provided answers. So there's three kinds of linear equations. There's three things that can happen when two lines interact. They can cross each other, in which case it has one solution. They can be the same line, just written differently, in which case there are infinite solutions because they overlap each other. Or they can be parallel. They will never cross. And that has no solution. And that's what we're looking at. When it has no solution, they have the same slope. Infinite solutions is same slope, same slope. Infinite solutions is same slope and same y-intercept. If it has those two, they overlap. If it's a same slope and a different y-intercept, then they are parallel and there is no solution. So not just same slope. Be careful of that because I can pretty much guarantee that one like this, they're going to include an option in there that has the same slope and the same y-intercept to try to mess with you. Okay, can you do this by graphing before I write everything out? You can. I think it's a little slower for this particular problem. Your mileage may vary. It's not a huge difference in this particular case. And granted, one thing you don't know before you start graphing is which answer it's going to be. Okay, let me pause for just a second, back up a little bit. The way you would solve this with graphing is you would type all of these into your graphing calculator, and you'd also type this one, and you'd see which one it matches. Now, what you don't know before you start that is the answer going to be near the top of the pack or is it near the bottom? You may end up having to type in all four before you get to the bottom. Or it may be a good day for you and you only have to type in the first one or the second one. You have no way of knowing. So it may be very quick. It may take a little longer. It's a little bit of a risk. If you are looking at this through this other sort of perspective, which I'm looking at, and you're very familiar with the slope-intercept form, it may be a little faster. Do what works best for you. Slope-intercept form is when y is by itself and everything else is on the right. The constant that is next to the x, the number, is going to be your slope. And the number that's the b, that's by itself. I keep writing slop. Why am I doing that? I'm writing and then I'm moving on before I finish the word. The b is going to be the y-intercept. Yes, I know how to spell slope. My brain's moving on and like, you don't need to finish that word. Nah, don't do it. Just write slop. And so it's y-intercept is the b. And all of the ones they provided are almost in this y slope-intercept form where y equals mx plus b, but they're not quite. They have all the x's over there. So this is standard form, where the x's and y's are on one side. Why I say it's close to slope-intercept form is because all the y's are single y's. They don't have a coefficient. So I'm not going to have to move the x's over to the other side and then divide everything by this coefficient to get y by itself. All I have to do is move the x's over. So if I'm looking at that, I'm like, okay, let me see if I can do this more in my head, as it were, instead of writing all these out. So what happens when you move something over? You're going to do the opposite. So here we have a negative 6y. So I'm going to add, 6x. So I'm going to add a 6x to both sides. So if I add 6x, it's going to get rid of that. I'm going to have 6x plus 18. And all of these are going to be that same way. It's just going to move it over to the other side and it changes it from a negative to a positive, essentially. So if I look at that way, like, okay, all those are going to disappear. And it's going to be, I'm writing it after, but kind of imagine they were in the other order. 6x plus 18, 6x plus 22, 12x, not 6, 12x plus 36, and 12x plus 18. So if I kind of look at it that way, either sketching that out really quickly or seeing that in my head, I don't have to type everything out. And then I can like, oh, okay, it's already in my y equals mx plus b. And what am I looking for? Again, it's two things. It is the same slope and it is a different y-intercept. Yay, I wrote slope, not slop that time. I'm improving. A different y-intercept. Now I'm double checking different. I'm like, please tell me I didn't misspell different when I wrote that. I did not. Yes. Okay, so the same slope. This one that's in the y equals mx plus b format. 6 is my slope. That is my slope. Is 6. And my y-intercept. I wrote slop again. For the love of Pete. What is with me today? I don't know. Okay. And 18 is my y-intercept. Some days you're just a little sloppy. What can I say? Today is a sloppy day. Slope. And 18 is the y-intercept. My brain has just decided, no, you don't need to finish words. Just move on. What are the slopes of A and B? They are both 6. That coefficient by the x is 6. Okay, they have the same slope. They're both contenders. What about C and D? No, for those, the slope is 12. They do not have the same slope. A and B pass the first test. Now we need different y-intercept. The y-intercept for the original line is 18. Let's see, in A, the slope-intercept, that number that's by itself, is 18. No, that is not a different y-intercept. Those two lines are the same. They would overlap. They would have infinite solutions. A is out. So it must be B. Let's double check it. It has the same slope. Yes, we've already confirmed that. And it has a different y-intercept. It has 22. That is it. And this is probably the most writing and mess that I've made on a series of answers when doing one of these. So let's clean it up just to be absolutely clear. We are saying B. B is my answer because if we wrote it, it would be y equals 6x plus 22, meaning it has a slope of 6, the same slope as the original, but a different y-intercept of 22. B is your answer. Number 24. Triangles PQR and LMN are graphed in the xy plane. Triangle PQR has vertices P, Q, and R at 4, 5, 4, 7, and 6, 5, respectively. Triangle LMN has vertices L, M, and N at 4, 5, 4, 7 plus K, and 6 plus K, 5, respectively, where K is a positive constant. If the measure of angle Q is t degrees, what is the measure of angle N? Okay. Now, if I were you, and I'm getting a problem like this on the SAT, there's a couple of ways you can go about attacking it. One is to give yourself a quick little sketch and kind of see where these points are going to be, and then, sketch your triangles out, do it that way. Or you could put these points into your graphing calculator, depending on your graphing calculator, if it'll draw that triangle for you. The first one, this LMN is going to be a little bit harder. Because we have this LMN with this K, this unknown constant, I'm inclined more towards sketching it. But regardless, what I did is I actually I went ahead and drew out just the PQR, and we're going to get this lined up on the grid that's in the background. There we go. Okay, so there I went ahead and drew a pretty accurate PQR with those points at 4, 5, 4, 7, and 6, 5, respectively. Right, so we have a couple of unknowns here, and they're wanting us to know what's the measure of angle N in this other triangle, LMN, of which we do not know the exact dimensions of it. We know point L is here at 4, 5 as well, so it's touching at the very least this other triangle, PQR. And we're told angle Q here is T degrees. And there's this K. And if we look at our answers, the measure of angle N, it's not a number. It's all in terms of T and K. So this is one of those things where it has to always be true. No matter what K is, this is always going to be true as to the measure of angle N. All right, so let's start by looking just at triangle PQR. And I'm going to draw it over here so we can kind of see it a little bit bigger. I'm going to draw it terribly over here. And we have a vertical line, a horizontal line, and they're connected. And we know, because we can look and we can just count, we can count the sides. This side is 2 and this side is 2. Okay, so 2 and 2. And this is a vertical line going up and down because they have the same x coordinate. And this is a horizontal line because they have the same y coordinate. See up here? And I'm almost cutting it off the screen. But those first 2 points have the same x coordinate. And those other 2 points have the same y coordinate. So horizontal line, vertical line. And when we have a horizontal line and a vertical line, they meet in a right angle. Now I'm hoping when you see this right angle and you see that both sides are 2, you immediately think of a 45, 45, 90 right triangle. It is an isosceles right triangle. All isosceles right triangles have base angles, those smaller angles, of 45 degrees. Always, 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 no exceptions. And this is that little pattern you learned. I'm hoping you learned. Please add this to your list if you haven't learned it yet, where it's a square root of 2 for the sides. That is available as a reference on the SAT, but I always advise learning it so you have that in your head and you know to be looking for it. So, okay, so it's a 45, 45, 90 right triangle. So we already know that T is 45 degrees because this is T right here. This is Q, there's P, there's R. So I already know that T is 45 degrees. Okay, but we're not being asked that. We're being asked, what is angle N? All right, so let's draw on what we think this must be. Now I'm going to pick a number for a number for K, not Q. Q is in there, the K and the Q and the bleh. I'm going to pick a number for K. And I can just pick any number, any positive constant I want, because my answers here all are in terms of K and T. So this must be something that no matter what number I pick for K, it's going to come out as one of these answers every single time for every value of K and what T is. Okay, so LMN, and I'm going to say K is equal to 3. That's my number I'm picking. All right, so L is at 4, 5. And then I'm going to write over here my point L is 4, 5. My point M is 4, 7 plus K. 7 plus 3 is 10. And then my point N is 6 plus K. 6 plus 3 is 9. And then 5. And looky here, we've got the same thing going on that we had with PQR. We have 2 x's that are the same and 2 y's are the same. So it looks like this is going to be another triangle with horizontal line and vertical line. Let's plot it on the graph. We have 4, 5 there for L. 4, 10 is going to be up there. There's my M. And then 9, 5 is right there. That's my N. And so try to draw the straight lines. Microsoft doesn't always like me drawing straight lines. It likes to go up. See, you can't draw a straight line. How about that? I'll connect it. So there, Microsoft Whiteboard. Draw a line if I want to draw a line. There we go. Close enough. It's not the best one. It's a little awkward in that corner, isn't it? There we go. Clean it up a little bit. Make it look a little nicer. There we are. Triangle LMN. And yes, it is also, it's sharing this right angle. We have those 2 sides there. And we have made another isosceles triangle. And no matter what value we put in for K, it's going to be another isosceles right triangle. Because think about what's happening. This M point is 4, and then it's 7 plus K. 7 was the coordinate right here. There's 7. So then K is this extra distance. And if we're on the other side, down on this side over here, what was the original point? The original point here was 6, 5, and then N is 6 plus K. So we've added another, this is K. K was added to the height of this triangle, and K was added to the base. So those sides are still the same length as each other. They're still congruent. So we have another isosceles right triangle. So it also will have 45 degrees on both sides. So I know now that angle N is 45 degrees. It's the same as T. Angle N is 45 degrees. Angle N is T degrees. It's the same, but that's not an option over here, is it? So you go, wait a minute, Alyssa, how am I supposed to do this then? Well, there's two sort of ways you can look at this. I'm going to show you the way that will work for every problem that's similar to this, and then I'll show you the way that works for this problem, an additional way. So the way that works for every problem is if you have a right triangle, and it could be not an isosceles, let's say it's a right triangle, it's something like this. This angle here being 90 degrees means the sum of the other two angles is also 90, because all three together equal 180. So if I have 180 altogether and I subtract that one right angle, I'm left with 90. These two together must be 90 because they're the two that are left. 90 degrees are left. So that's always true of a right triangle. This right here is a right triangle. It's a right triangle. And so this one being 45, you could say this one is 90 minus 45, or 90 minus that angle. It just so happens that they're both identical. They're both 45. So we could say 90 minus, like this angle down here, if I zoom in so you can really see what I'm talking about. Like, and use a different color. Let's use like bright blue. There we go, baby blue. So like this angle right here, I could describe it as 90 minus t, that t, because these two together would be 90. So if this is t, that must be 90 minus t. That's another way I could call it. So 90 minus t. And the same thing is here. This one's 45. This is 90 minus 45. T is 45, so I could replace this with t, and this could be 90 minus t. And that is what it is. It is 90 minus t, which is C, my answer. And that's the sort of perspective that could get this problem right, no matter what the other answers are. In this particular case, however, C is the only viable answer because T is the one related to degrees. K is a constant that is related to the length of the sides, not the angles. If we're talking about proportions or how the sides relate to each other, then we'd be talking about K. But we're not. We're talking about the angles. K is not related to the angles at all. And A, B, and D all involve K. So just that right there, you go, wait a minute. K is about the length of the sides. That's not changing these angles. No matter what K is, these angles stay the same. If K had my triangle, if I picked a really big K and it was like all the way up here and all the way out there and all the way out there, these angles are still 45 and 45 degrees. K got way bigger, but those angles did not change. So K getting bigger or smaller would change the other values. It would change A, B, and D. So that's impossible because the angle doesn't change. It's always going to be 45. And as K got bigger, that number, plugging that in, would change. So just the fact that K is in answers A, B, and D means they are ineligible for this, and it must be C. But like I said, the way I was telling you about how the opposite of the remaining angles in a right triangle add up to 90, that will get it right on every question, not just this one where they gave you 3 answers that are impossible. All right, and that's 24. My answer is C. Number 25. I'm guessing I'm going to have a lot of people watching this one because there was another problem that was very similar to this in a previous practice test, and it had a lot of people wanting to know how to do it, and I don't blame you all. This is one, when you look at it first, it's a head scratcher, but then we have to look a little closer and all shall become clear, I hope. That's my job, right? To make it clear. Right, we have 2x plus 3y equals 7 and 10x plus 15y equals 35. For each real number r, which of the following points lies on the graph of each equation in the xy plane for the given system? Yeah, okay. First things first. It says, which of the following points lies on the graph of each equation? So one of these four options has to be true for both of these. And you go, wait a minute. How is that possible? How can one equation, how can one ordered pair with a real number, and it applies to all real numbers? That's what it says. Random ruler out of nowhere. I love doing that. It says for each real number r. So all real numbers in the universe, I plug this in. It's going to work in both equations. How is that possible? Well, it's possible because they are the same. They're the same line. Exactly the same. They're just messing with you by writing it twice, just to really make this hard problem even harder. So first, 2x to 10x. How would you get from 2x to 10x? You would multiply by 5. How would you get from 3y to 5y? You'd multiply by 5. And how would you get from 7 to 35? All together now, you multiply by 5. This is the same line written 2 times. If you put this into Desmos, you would also be able to see that. That's another way you could reach that conclusion. But yes, they are the same line. So let's forget about that 10x plus 15y equals 35 because that's a more complicated one. Let's just focus on 2x plus 3y equals 7. And what do we have here? What is this? It is saying if I pick any real number, the x and y value will somehow be represented by this. Now this first one has fractions and numbers for both, but these other three, there's something interesting going on. This one has r as a y value, this one has r as the x value, and this one has r as the x value. So let's take this and say, if I solve for x and then I solve for y, what am I going to get? And then we'll bring r into the equation, into the discussion. All right, first I'm going to solve for x. Get x by itself. So I have 2x plus 3y, the opposite of, let's change this to green, plus 3y is minus 3y, so I'm going to subtract 3y from both sides, and I get 2x equals negative 3y plus 7. Now, 2 is multiplied by x, or x is multiplied by 2. To undo that, I'm going to divide by 2, and I have to do that to everything to keep everything nice and balanced because it is an equation after all. And I get x is equal to negative 3y over 2, or we could also write that negative 3 halves y plus 7 halves. And if you see that this looks awfully similar to things that are showing up over there, then you know, I think we're on the right track. Okay, so I'm going to keep this, that x is equal to that. And now I'm going to look at what happens if I solve for y. 2x plus 3y equals 7. Well, I'm going to subtract the 2x to move it over to the right-hand side. Since it's positive 2x, I'm going to make a negative 2x. And I have 3y on the left, and then negative 2x plus 7 on the right. And then on the left, I have 3 times y. I want to divide by 3 to get rid of that. Divide everything by 3. And I am left with y equals negative 2/3 x plus 7/3. Okay. What does this mean? And you're like, okay, that's cool, and it's very close to what's going on. Here is what it means. It means that if I was to pick any random number, let's start with this one first. Let's do this one. If I was to pick any random number, a y value, so I picked a random y value and I plug it in, my x is going to be equal to negative 3 halves times that y value plus 7 halves. Right? Now what does this one mean? The y being negative 2/3 x plus 7/3. It means that if I pick any random x value, then my y relative to that x would be equal to negative 2/3 times that x value plus 7/3. So these are the two ways we could represent it. Is I pick a y, and then the x value is equal to negative 3/2 times that y plus 7/2. Or I pick an x, and the y is equal to negative 2/3 times that x plus 7/3. Well, let's change it to, instead of saying I picked a y or an x value, I just picked a number to put in, a real number. Oh, I don't know, a real number called r. Sorry, that was really dumb sounding. Anyway, sorry. So I have a real number r. Both of these are possible. It could be, if I pick any real number r and I plug it in for y, then the x value for that ordered pair would be negative 3/2 times that real number plus 7/2. Or I could pick a real number and plug it in for the x value, plug it in for x, excuse me, and then my y value is going to be negative 2/3 times that r plus 7/3. Now I just have to see which of these is represented over here. The first one, A, is not at all, and looks like B here matches this one, but let's just keep looking, make sure we've done things correctly. And C is very, very close to this, very close, but look at the one thing that's missing. This is a negative 2/3, and this is not. It's a positive. That's why C is off. So close. It's so close, and very easy to mistakenly get C, because it looks just like that except for that negative, and the negative makes all the difference. And D is backwards. It's reversing these two. And that's another easy one to get. Like, even if you got this far in figuring this out, it'd be very easy to kind of get them flipped. And no, it's when you get to this point, it's not saying that you put that you're putting this in over here and you're like, okay, and then the y is there. Just be careful. This is saying x is equal to that, so you plug this in for the x. Yeah, because some people might say, okay, then x, and then this is my y value, because I got x by itself and then the y. No, x is equal to this, so it replaces the x in the ordered pair, and the y just stays as it is. That's how that works. Is this a crazy problem? Yes, it is. It is indeed. Make sure I've crossed that one out so it's very clear. B is the answer. And again, they've done this before, and they hear it showing up again. So even though it's a rarer type problem, I've seen it on 2 different practice tests this time, and another time I've seen it. So that's shows they like it, and it might show up again. So good one to know. Answer is B. 26. X squared over the square root of x squared minus c squared equals c squared over the square root of x squared minus c squared plus 39. In the given equation, c is a positive constant. Which of the following is one of the solutions to the given equation? Okay, so the method that we're going to try to use here is we're going to try to solve for x. We know that c is a constant. We know that it's not a variable, so we just need to get x by itself. So it's x equals blah, de blah, and then that will be get our solutions. And this module, man, I feel like it was kind of lulling you into a false sense of security up to about number 23 or so, and then 24 to 27 is just like, whoa, all bets are off. And we have this monster. Now, I'm going to be straight with you. The first time I did this, because I always take these tests myself before I explain them. That's only fair, right? The first time I did it, I took a wrong path. I absolutely did. Here's where I went. I went down combining those two together, turning 39 into a fraction so I could combine, and then I can multiply by both of these and get rid of that. And it led me down sort of blind alley, and I got stuck on the x squared minus c squared being like a difference of squares, and that's not the way to handle this one. So yeah, especially when there's this much many moving parts. I'm not saying it's impossible to get to a solution of x with this, but I think it's too easy, especially if you get stuck on the x squared minus c squared like I did, to go down the wrong way. And I had to backtrack and go back and go like, no, this is not working, and then take another tack on it. It happens. It absolutely does. So here is the way I recommend to go forward with this. And honestly, I think the x squared minus c squared is a little mean because it does make you think of difference of squares. You're like, is that what it is? It's almost like there's too many ways you could tackle this that'll lead you down wrong paths. Okay, so the way that I would look at this is that you're going to subtract the c squared. Okay? You're going to subtract all of this from both sides so that all of the x's and c's are all on one side. So let's do that. So we're going to subtract c squared over the square root of x squared minus c squared, and do the same thing over here. Subtract minus c squared all over the x squared minus c squared. And that is going to give you on the left-hand side x squared over square root of x squared minus c squared minus c squared all over the square root of x squared minus c squared equals 39. Those cancel out on the right. Okay. Because this is so many steps here, I'm going to erase this and kind of move this back up to the top. Because it's going to get a little small. And I know, I'm recording this late. I shouldn't because my handwriting is getting really bad, and I apologize for that. I'm sorry. I'm sorry. That's poor planning on my part. Should not constitute a poor teaching experience for you. I'm sorry about that. All right. So because these have the same denominator, I can combine the numerators. So on top then I have x squared minus c squared. I've combined those because these are just fractions. We can combine fractions just like if I had, 2/7, minus 1/7. Seventh stays the same. 2 minus 1 is just 1. Okay, there we go. On the bottom, we still have that square root of x squared minus c squared, and that equals 39. So then the next thought is kind of like, okay, how do we go from here? I'm not going to lie, I don't think this is a really great problem to test your ability to do this kind of thing, because there's so many different ways you can try to tackle it before you find the way that's the right way. For a timed problem, I don't think that's really nice to have like all these different ways you can try and then go, oh wait, that's not working, I have to backtrack. Because like from here, you might think, okay, well I need to get rid of this square root here, so I'm going to multiply that on both sides. Okay. The best way to get out of this is to square both sides. And I don't think that's the first thing that would come to mind. The only thing that might make you think that is the answer, or that's a possibility, is if you look over at these options, you'll see that 3 of them have 39 squared. That's really the only clue that you should square both sides to get out of the mess at some point. Other than that, I think it's a little vague as to which way you should go. Now, when you square both sides, on the left, you're going to get, because you're multiplying, when we square it, we're multiplying it by the same thing. X squared minus c squared all over square root of x squared minus c squared. So on top, you're getting x squared minus c squared times x squared minus c squared. Don't distribute. Another hint that you shouldn't be distributing or expanding things is the fact, again, that they have c squared and 39 squared over here, and they're leaving things as they are. And all of that is over this. When you multiply these two square roots together, it gets rid of the square root because it's the same number. Square root of the same number times the square root of that number just equals the number, like square root of 10 times square root of 10 equals 10. Okay, so we're just left with x squared minus c squared on the bottom. Actually, I'm going to write that in red. There we go. X squared minus c squared on the bottom. And on the right, we have 39 squared. Okay, so then on the left side, because I have matching x squared minus c squared on top and bottom, and they are being multiplied on the top, not added, I can cancel one of those out. And we are left with, on the left side, x squared minus c squared equals 39 squared. And I'm going to move this over here. And then the next step we would do is we're going to add c squared to both sides. And that gets rid of the c squared on the left. So we have x squared equals c squared plus 39 squared. And then to solve for x, we would need to square root both sides. And that gets us to x is equal to plus or minus the square root of c squared plus 39 squared. And I'm running off the page. So because that's plus or minus, it could be the positive square root of c squared plus 39 squared, or the negative square root of c squared plus 39 squared. And that is D, negative square root of c squared plus 39 squared. Do I like this problem? No, I don't. I don't like it. I don't think it's very fair, frankly, because again, the way that it is presented, you have a radical in the bottom, you have difference of squares available. I just think there's way too many different ways you could try it, and I think it's reasonable for a student to try those ways before they sort of stumble across the correct way. And I say stumble because, I mean, if I'm wrong, please let me know. If you see a way that kind of indicates that the way I just did it is the best way right off the bat without going down those alternative, wrong, dead-end ways, I would love to hear it, honestly, because I'm not seeing it on this one. A lot of times there are indications of saying, like, no, this is clearly the way forward. But this one I don't think there is. And I think there's at least 3 different ways that you can start trying to find the answer before you came to this one. And again, it's a timed test, and I don't think that's a good measure of your skill at isolating the variable. Because if you went another way, it wouldn't mean you were bad at this kind of thing. It would just mean you arbitrarily picked the one that they weren't looking for in this problem. And that's not a good test question, in my humble opinion. But again, if you look at it and you go like, oh, well, this is the reason why you do it, absolutely, I'm not being sarcastic. I would love to hear it, because I always like learning new things, and this one, I didn't see it. I had to try a couple times before I found the right way. So yeah, I would love to know your take on it. All right, but D is the answer. Number 27, the quadratic function g models the depth in meters below the surface of the water of a seal, t minutes after the seal entered the water during a dive. The function estimates that the seal reached its maximum depth of 302.4 meters 6 minutes after it entered the water, and then reached the surface of the water 12 minutes after it entered the water. Based on the function, what was the estimated depth to the nearest meter of the seal 10 minutes after it entered the water? Okay, first off, what's happening in reality and what's happening on this graph are 2 different things. In reality, here is the water, and then we have our seal. Let me see. Kind of hard to draw on a, wow, that's a really bad, this is a really bad little seal. So, okay, I'm going to have this little seal. I don't know what happened there with that chin. Oh, this is sad. I need to see a seal profile in order to do this. He's got like little flippers that come out. It kind of comes around, has little pinniped kind of things. All right. Anyway, that's my bad representation of a seal. I need to see a seal. I need whiskers. I need to see a seal from the side, and then I can draw it. But anyway, all right. So there is a seal at the surface of the water. In reality, this seal dives down, and 6 minutes, it takes it 6 minutes to go all the way down, and it goes all the way down to 302.4 meters, and then it comes back up, and it reaches the surface a total of 12 minutes after it entered the water. So it took it another 6 minutes to go up, and this whole thing took 12 minutes total to go all the way down and come all the way back up. And they're wanting to know, where was it at 10 minutes? So like around here, how deep was it? That's our question. How far down was this? But here's the thing. This parabola where it goes down and comes up is not the parabola that we're going to be graphing. The parabola we're going to be graphing is going to go up and then come back down. So when you see that, or if you're checking this on your graphing calculator and you see that, Don't be shocked by that. That's what's happening, because this meters here is a positive number. It's starting at 0. A surface level is 0, so it's starting at 0. And then 6 minutes later, it reaches 302, positive 302.4. So we have to treat it as that number. It goes to a positive 302.4, and the coordinate there is 6, 302.4, because this down here is our time. That's our t time. And our depth is our y value for this is going to be our depth is on the y-axis. So after 6 minutes, it's at 302.4, and it's starting down here at 0, 0. And then it goes all the way back up to the surface, and it's 12 minutes later. So that would be at 12, 0. So we have 3 points on this parabola. More importantly, though, we have the vertex. That's a big thing. The vertex is, our highest point, and we can tell it's the highest point too. It's confirmed by the fact that it's 6 minutes up, 6 minutes down, and those are our 2 zeros. So that's smack dab in the middle between the 2 zeros is going to be your vertex. That's how it works. So we have this. Now, how do we get an equation or a function from this information? Well, if we have the vertex and one other point, we can use the vertex form of a parabola to create this function. So that's what we're going to do. All right, I'm going to erase my little sketch here and my little oddly drawn seal. Okay, now the vertex form of the parabola is very closely related to what I was saying back on question 10 in this module about translating functions, moving them around. And it's that pattern I talked about where, let's say if you have, like x squared, you want to move it left and right, or you want to move it up or down. You'll make it wider, narrower, flip it. It's all those numbers that you put on, outside of it. So if you want to move it up, you add a number on the outside. If you want to move it down, you subtract a number on the outside, like outside of this central x squared. If you want to move it left or right, then you put a number in with the x squared, and it's the opposite. So if you want it to go to the left, towards the negative x, you add. If you want to go towards the right, towards the positive, you subtract. Then also, if you have a number out here, if it is a number greater than 1, it makes it the function narrower. If it's a fraction between 0 and 1, it makes it wider. If it's a negative number, it flips it upside down. So, okay. All that sort of thing is why this vertex form that I'm about to show you, and again, I went through that very quickly. If you want all the little details and actually see it in action, please go back and watch. If you're watching the long form of all the numbers together, go back and watch the part for number 10. If you're watching them as separate videos, go back and watch the video for number 10 in this module. So the vertex form is a times x minus h squared plus k. Now, a standard parabola has its vertex, bad parabola there, at 0, 0. That is the standard parabola. Vertex at 0, 0. So if I am moving this left and right or up or down, that vertex, I can move that vertex, and that's going to be sort of my touch point as to where it goes. Well, how about this up here? What do you think the vertex is going to be? This is the vertex form. Now, I already said with a function, this moves it up and down, this moves it left or right. It's moving that vertex up or down, left or right, that many. It's starting at 0, 0. So that h and that k is our vertex. Now, a is that factor that's making it wider, narrower, is really making it more interesting than just a standard parabola. Now, we don't know what a is yet, but we do know the vertex, so we know our h, we know our k. So let's plug those in. We have a, and it's x minus h, that minus, and then whatever the h is, you put it in. If the h is a negative, that's our x value for the vertex. If it's negative, then you put the negative there, and it becomes minus a negative or a positive. be careful on that point. This one, our x is a positive 6, so it's x minus 6 squared. And our k is 302.4, that y value of the vertex. This is going to be equal to g of, actually this shouldn't be x, it should be t. I'm going to make it right. T minus 6, there we go. And it's g of t. All right, so we've plugged in what we know. It's quadratic function g. T is the number of minutes. That's essentially our x value here. We don't know what a is, and we have to know what a is in order to answer this question, to figure out where the seal is 10 minutes when t is 10. We don't know what a is. The way you solve for a variable is you get rid of another variable, right? You get it so there's only one variable in the equation. At the moment, there's two. There's a and there's t. We got to get rid of one of them. Well, we have two other points. We have 0, 0, and we have 12, 0. So we know that if I am to plug either of these points into this equation, I know what I'll get. I know if I plug 12 in, I will get 0. I know if I plug 0 in, I will get 0. Okay, this is good. So I'm going to plug 12 in here. So I know that g of t, in this case, g of 12, if I plug in 12 for t, I'm going to get 0. So let's do that here. I'm going to plug in a 12 for t, and I know that's going to equal 0. So 12 minus 6 is 6. 6 squared is 36. So 36 times a plus 302.4 equals 0. Well, that's much nicer. Much more straightforward. So let's solve for a here. We're adding 302.4. We want to do the opposite of that. So we subtract 302.4 on both sides. And we get that 36a is equal to negative 302.4. Now, since it's 36 times a, we want to do the opposite of that to get rid of it. So we divide both sides by 36. And we get that a is, that's a really bad a. My computer screen wobbled as I wrote that. My a is negative 8.4. Woohoo! Now I know I can go back into this version up here, which is the ultimate version here. I can put in negative 8. Can't write worth a flip. All right, negative 8.4. That was not any better. Negative 8.4. And it's x minus 6 plus 302.4 is equal to g of, and I still wrote x, good night, t, g of t. I always want to say x. I'm like, I don't like t. It's going to be x. All right, so negative 8.4 times t minus 6 squared plus 302.4 equals g of t. Is it possible my handwriting is getting even worse? I don't know. I didn't think it was, but here we are. Right, now I know my equation. This is it. This is the seal tracking equation. I'm going to erase that 3 that has a dot in it. I'm going to make it a little more, slightly more reputable. All right, I'm just making things worse. Okay, now I need to know 10 minutes after the seal entered the water, when t is 10. What is this? So I'm asking, what is g of 10? Well, let's figure that out. Let's plug in 10. So negative 8.4 times 10 minus 6 squared plus 302.4. 10 minus 6 is 4. 4 squared is 16. So 16 times negative 8.4 plus 302.4 is going to be equal my g of 10. And negative 8.4 times 16 is negative 134.4. No, I did not do that one in my head. I actually had it written down here. I came prepared today. Plus 302.4. And when I add those together, I get 168 is my G of 10. So 10 minutes after the seal entered the water, it was at a depth of 168 meters. 168, that is my answer. So, yeah. At this point, once you get to this, you can put it into Desmos. You could absolutely do that. And then you can see, when x is 10, what the value of y is. Totally viable way to do it. I can't think of any way offhand that you'd be able to get to this without knowing the vertex form of it. Or I should say quickly get to it without knowing the vertex form. I'm drawing a blank on any other method. As always, as I invite people often, I'm like, hey, if you know another way to do this, there's often more than one way to do a math problem. I'd love to hear it. Please comment that down below. Let me know if you have a different way that you would do this. Yeah, I want to know. But I think vertex form is probably the most straightforward way to do it. But I also see that causing a problem for a lot of students because vertex form is not something we use that often. We just don't. But hopefully, if you practice the concepts that I covered back in problem 10 about translating functions, it'll make a little more sense why the vertex form is the way it is, and maybe it'll make it easier to remember for those oddball questions like this. And that's it. You have reached the end of this section, this module. Congratulations. Hey guys, it's Alyssa, and if you're looking for more SAT or PSAT help, go to mathwithalyssa.com. You can get over 25 hours. Yes, 25 hours of test prep, including math and reading and writing. And there's dozens of practice questions, downloadable study guides, you name it. Links to everything in the description down below. Leave me a comment if you have any questions about this video or any suggestions for future videos. And if this video was helpful or useful in any way, please let YouTube know. Like, share, comment, subscribe, you know the drill. Thank you so much for watching. Hope you have a great day. See you later.